Hello, this is Mr. Stansbury. I'm going to take you through the 10 notes on three-dimensional problem solving. At the end of this, you should be able to say that I can find various measures of 3D shapes using trig ratios. All right, so let's jump straight into some examples. First one's example 12 from page 332. And it says a cube has sides of length 10 centimeters. Find angle CBA. Okay, so CBA. So we want to figure out what this angle, oh, that's rotten. That's a little better. We want to figure out what that angle right there is. All right, so what we want to do is kind of take a look at this a little bit different way. Let's look at it as we're looking straight down on top of it. And that would be A, and that would be C. And we know that, let's see, the cube has sides of length 10 centimeters. So this is 10, and this is 10 centimeters. And this is a cube, so these are all right angles. So we need to figure out how long this piece here is, right? So really what we can do to figure that out is just do, easiest way is just a squared plus b squared equals c squared. And again, that is not 9 squared, but a squared. All right, so let's do 10 squared plus 10 squared equals c squared. So we have 100 plus 100 equals c squared. So there's 200 is c squared, and then we square root to get what our c side is, this one here, and that's going to be the square root of 200. Now it's going to be handy to actually have a actual decimal answer here so that we can plug it in so we can figure out this other stuff. So let's figure out what that is. So we've got square root of 200, 14.1421, blah, 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 blah. So let's do 14.14, and this is what, in centimeters? And the farther, honestly, the farther out you go in your decimal places here, the more accurate answer you're going to end up with. So we'll go with 14.14. So now we know that this piece right here, 14.14. All right, and we know that this is 10, so let's redraw this triangle here as, if we take a look at it from the side, here's A, here's B, and here's C. Now we know that this has got to make a right angle right here, and this is the angle that we're looking for. We know that this length here is 10, and this length here is 14.14. So now we have enough information to find out what that angle is. So from that angle, this side is the opposite, that's the adjacent, so we'll do tangent theta equals 14.14 over 10. So again, since we're calculating an angle, we're going to do second tangent of 14.14 divided by 10. Hit equals, and we get 54.7 degrees. So theta equals 54.7 degrees. So that is angle CBA is 54.7 degrees. All right. Okay, so there's our first example. Let's take a look at another one. And this is example 13 from page 334. And this is like shadow or projection type questions. So it says each of the following, so find the shadow or projection of each of the following in the base plane if a light is shown from directly above the figure. So if a light is shown from infinitely above, so basically like the sun is shining down on this, they're asking what would be the shadow of UP. So here is U and here is P. So basically they're saying, okay, if you have this line here, oh my gosh, look at how beautifully straight that was. For me, that's pretty good. Come on, you got to admit. So anyway, if you shine a shadow down on that, they're asking what would the shadow be, and if you shine a shadow straight down on that, it's going to be, for A, it's going to be TU, right? Because it's shining straight down on top of it, is going to shine right down and make this line TU. All right. So again, you got to think of a light being shown from directly above this line PU, which would again cast a shadow on TU. All right. For B, WP. Let's do these in different colors so this is easier to understand. So B is WP. So here's W and here's P. So to make this shadow here, if it's shown from straight above, is going to be WT. All right. C is VP. So here is V and here is P. So if we make this line here, if we cast a shadow from straight above, it's going to make the line TV. All right. And then the last one is XP. So here's X and there's P. Oh, see, that's what happens when I got all excited that I was drawing such beautifully straight lines. Oh, that one's worse. And now look what happens. Oh, justice. Oh, that's terrible. I'm going to get this right. We might be here for a while, but I'm going to get this right. Oh, gosh. Come on. There. All right, close enough. So if we make the shadow from X back up to P, that's going to make the line TX. All right, and that's really all there is for these problems here. All right, so just casting shadows. All right, so next